Oops. I'm sorry. Got kicked out. My browser restarted. Give me a second. I'll find the presentation again. Uh, uh, uh. Okay. Let me share it. I hope everyone can see it.
Yes.
Yes, I can see it.
Okay. So we are building a web platform for computational design, and it consists of a few things. The core is BeeGraphy editor, which is a computational design tool, and then there is a BeeGraphy market where designers can publish their designs for portfolio purposes, just to demo their skills, or to monetize their talent, or just let everyone enjoy their work. Download the fabrication production ready files with custom parameters. So the uniqueness of that, unlike all other marketplaces for 3D models, in BeeGraphy, everything is parametric, so anyone can change parameters and download. Our focus is on democratizing computational design. We think computational design is very powerful, and right now it's quite limited. It's a niche thing, but we want everyone to to enjoy the benefits of computational design. Uh, so a few words, BeeGraphy is already being used in 114 countries. In some countries, it's being used in education. We highlighted them in our BeeGraphy yellow color. And yeah, this was just a picture from some of the classes where BeeGraphy is being used. And I'm gonna keep it short. I want to give the floor to Abhishek, the co-founder, or no, the founder. I don't think he has other co's of the Uni XYZ, the platform where we host a competition dedicated um, to computational design. We call it BeeGraphy Design Awards. Abhishek, do you want to share your
Sure.
own slides? Or
Sure, Lanik, I'll share my.
okay.
Hello, everyone. So let me just share quickly my screen. Yeah, is it visible to everyone?
Yep.
Yep.
Great. So just to begin with, we launched the BeeGraphy Design Award, which is in the computational design field for everyone, where everyone can learn and then put their work on BeeGraphy and work on different real-world problems as well with the computational design. So we are right now creating it in 10 categories, which is furniture and home furnishing, fashion and jewelry design, lighting design, education, and many more. There is a miscellaneous category also where you can submit anything which you want, which is apart from all these categories. So it's open in a way for all the design disciplines. And the entry fee, there is no entry fee to this. It's free for everyone. And across 10 categories, we have 7,000 USD of prize money. In these manner, like winner, then there is runner-up and best in each of these categories, winners in professional and student as well. And we have a team of experts over here who will be judging all the entries that you guys will be submitting. And this is just some of the jurors here, but there are many more, which is listed on the BeeGraphy Design Award page on Uni. And stage 2, where you'll be detailing and submitting your design along with the, the computational design file, which will generate on the BeeGraphy, along with some presentation, the concept behind it, and some rendered visual as well. So this will be stage 2. And let me just quickly show you this time, like how to navigate if you haven't navigated to the BeeGraphy Design Award page and how to submit the entry in the first stage. So you can simply search, navigate to the main page where all the award details are here. And on BeeGraphy, you can simply submit your model. So BeeGraphy is the editor which today you'll be learning about all these things and how to publish it on, these marketplace. It is a bit slow. So you can go to market, and all these people who have recently been participating are submitting their models over here. So you can browse through their models as well. So these are the different kind of submissions which we have been receiving lately. So we just wanted to showcase that to you. There is no limit to how many number of model you can submit, and it can be from any field, as I have already explained earlier. So there is some lighting which has already been submitted. We will learn some today how to create that. And this is the page where you can learn about each of these categories detailed, what are the design criteria, and how you'll have to create it. So for art and collectible and urban furniture, which we'll be learning today. And additionally, you can explore the jurors detail over here who are in this award. We are updating consistently with new jurors in this. You can check the detailed schedule of this whole series that we are running. And if you have any discussion, you can navigate there. And don't forget to check the competition rules also, what will be there in the second stage of the submission, right? So this is a brief overview. And we have already showed you the marketplace, and we will learn how to publish it to the marketplace as well today in the workshop. So thanks. I'll now hand over the mic to Ayush, who will be taking the workshop and introduce the
Thank you,
coding.
Abhishek. Thank you, Danik, for the wonderful introduction to BeeGraphy. So before we jump into our actual action for the day, let me just share my screen as a brief introduction to who we are. So we are representing CODIN. So we are like partners with Uni and BeeGraphy to organize the workshops, to bring these free workshops for you. The BeeGraphy team was very generous to keep all the workshops free and accessible, which completely resonates with the main idea behind BeeGraphy, to make it collaborative, inclusive, and bring parametric design to all. So we are CODIN. We are a group of collective and a group of designers who wants to bring design innovations to everyone, to make it accessible for everyone. That is our main motto, because we see that there is a big gap in current design education. The skills that are demanded in the industry are not completely given out in the universities. So in 2022, we came together and started this organization. So CODIN is part of a larger ecosystem where we do some architectural consultancy, some startup incubating, some competitions, and so yeah, it's an ecosystem that takes care of every aspect related to design. The three main keywords that we believe and that we live on in CODIN is innovation, exploration, and upskilling. So this is what we will try to bring, and this is what we will try to deliver it to you today as well. Something innovative, something which you can explore on your own, and definitely you will be upskilled during the workshops. So we do a lot of online workshops, some studios, and university courses as well. This is the portfolio, the kind of courses that are being offered right now, and the workshops are being taken around the world. This is the team. It's me, Safid, and Divya, who will be taking care of the workshops today. Our mission and some of the works from our previous courses. So both online, offline, digital fabrication, sustainability. So it's like a big range of courses. But without wasting any further time, we are done with the intros, and let me just quickly tell you what is on the cards today. So this is the workshop 2. There are a total of 4 workshops in this whole series, once every month. It is usually on the second Saturday of every month. So the next will be happening on the second Saturday of September and the final one in October. And we are going category wise. Today we will be looking into 3 categories. The first one is lighting fixtures. This will be happening at 12:15 to 1 GMT. So just convert it into your local time. So this is the kind of things which we will be in this session, which will be the first session of the day. Then we will have like a small break and a Q&A session. And then we will go to the second category for the day, which is DIY and engineering. Divya will be heading this. He's a master's in digital fabrication design from UCL London and is a domain expert in this area. And we will be learning to create like a frame of a drone, which you can 3D print at your home. And the final session today will be at 2:15 to 3, which will be about urban furniture. And we will look into these kind of waffle outdoor furnitures. We highly encourage you to follow the entire workshops because there are a lot of dependencies. It's like a linear progression. What we learn is passed on. Some elements are passed on to the next one, and it will be super fruitful for you to stay for the entire time. But if there are certain time constraints, then please join to the sections which are the most relevant for you. Perfect. Let's get into our action now. I start sharing my screen again. Our first category, which will be the lighting design. And we want to learn, this is our target after spending 45 minutes with us, you will be able to create this kind of a fixture, which is parametrically controlled on your own. Feel free to ask your questions in the chat. If there is any doubt, anything, be it small, something is not understandable, the logic is not clear, so feel free to ask anything there. Any of us will, we are a big team here assisting you, so we'll be able to answer you instantaneously there. And if you are completely new to BeeGraphy, as I told you that this is a workshop series, we are on workshop number 2 now. There is already the videos of our workshop 1 in the uni.xyz platform, where you can learn the basics of BeeGraphy. So I highly encourage you to visit that as well. If for certain reason you were not able to join in our workshop number 1. So if you go to the competition and learning resources, there are a lot of tutorials by Jose, by Gediminas, and our first workshop about the basics of parametric design and introduction to BeeGraphy. So highly recommended to check this out. Perfect. So this is our intention for the first 45 minutes. And let's get right into it. A simple interface. I saw that some of you do not have a BeeGraphy account. So please get your account, please create your account, then log in. Once you log in, the login sign up is completely free. There is no restriction on what you can use, what you cannot use. All the tools, all the advanced things are at the moment completely available for everyone in the free version as well. So as Learning already introduced, there is an editor and a marketplace. So our first interaction will be with the editor, in which it's like a blank canvas where we are trying to create the form that we intend to get out. As soon as you go to the editor, there is this page you come across. All of your data is, rather than being stored locally in your drive, is already on cloud. All your forms which you have explored in BeeGraphy are already available here. So we are going to create this form from the very beginning. So let's jump into creating a new model. So this new model will open up a blank canvas, like a new Grasshopper file or a new 3D modeling file. You can give a name to your model. For me, I can say it's lighting fixture. There is no restriction of the name. You can do whatever, you can put whatever you want to call it. As soon as it's created, we see something like this. You are already familiar with the BeeGraphy interface, but let me spend like a couple of minutes to refresh your knowledge and to, yeah. So this is where we see the actual form. There are these settings where you can control what you want to see, whether you want to see the grid or not, and what is the quality. So a low quality will be faster to process, a higher quality will take some time. Then there are different view modes, whichever you want to see. So this small window, which will always be there, is similar to what you see on the Rhino thing. If it is for those people who are only familiar with Rhino till now. So your geometry will be real time visible here. And this becomes like your grasshopper canvas where you can drag and drop any components. Again, you can just double click and type in whatever the component you would like to take. For example, if I want to take create a circle, there are multiple kinds of circle. I want to create a circle with a center and a radius. So I just create this one. And then you see that immediately this is visible in your graphical user interface. And interesting thing, as soon as I select something, the color changes to yellow. So you can easily identify which element is resulting to what geometry. The way where it gets even better than Grasshopper and Rhino interface is that it is reverse compatible as well. In Rhino, it is just one-way compatible, that if I click on Grasshopper, I can identify the geometry inside the Rhino. But if I know the geometry, I cannot find the element, which is not the case here. So here we can select the geometry as well, and the component will be visible. I am not sure why it is not happening right now. Let me just reload it. Yeah. So selecting the geometry will lead to highlighting of the component as well. Perfect. So this, and here are all the different components. Some core components, the materiality, exporter, list, tools. If you cannot see some of them, there might be like a small drop-down menu. And from there, you can select it to get activated, and it will be just pinned. So a lot of tools already inbuilt, from panelization to arrays to lofting to image processing and so on. And we are just going to use all these native components to create our form for today. Great. Then let me start with a whiteboard. This is our target geometry that we want to achieve. And then let's see how we can parametrically break it. What could be the way we can achieve this kind of a form? So what happens? When I see the geometry, what I realize that it is predominantly an extruded cylinder, but there is this tilt in the center. If I look from the front side, I realize that this bulge, this is not parallel to the horizontal plane. Like if there is a circle here, if there is a circle here, this circle is not straight. It is not parallel. It is like somewhat tilted. So if I just try to draw it, what it may look like. Let's say this is our circle on the top. This is our circle on the bottom. So rather than being parallel to our two circles, the top and bottom, this seems to be tilted in this fashion, the one which you can see in the red line. Exactly. So this is somehow we want, this is like the first apparent thing which I can see. Again, one thing related to parametric design in general, I would like to share that there is no right or wrong method in parametric or computational design. There are hundreds of ways that the same result can be achieved. In the time constraint that we have today, I will be following a one or a two approach to reach this particular end result. But it doesn't matter that it doesn't mean that all the other ways of reaching to the same form are wrong. There is no right or wrong. There is just more efficient and less efficient ways. So there could be some ways which are, let's say, less taxing on the computational power, which are easier to achieve, which uses less components. So we always thrive to follow that processes in which our input, our investment of time, our computational resources is the least, and it results in the same outcome. But for in the beginning stages, even if the process is not super streamlined, not super optimized, it is okay to follow that process. That slowly, we will start to get that intuition that, okay, this can be done in this way as well, which could have given the same result, but in a faster way. So one thing we are clear now that there is this one circle we want on the top, which is horizontal. There is one circle we want on the bottom, which is again horizontal. And then there is the tilted circle in the middle. And then if we are able to somehow connect them smoothly, all of them, we get closer to what this form is trying to achieve. But certainly not in a 2-dimension. It is all happening in a 3-dimensional in circles and cylinders. So let's be easy. Let's start slowly and put these 3 circles in and then see what happens. So let's start with the bottommost circle, which is this, and you can choose whatever the size. So it's mainly based more on proportions rather than trying to identify the actual size at the moment, because we are in the exploration phase. So let's say I am having the bottom radius, which is this red circle, as 3 here. Perfect. The good part again about BeeGraphy is that I do not need a separate component or an element for all the input. In Grasshopper, it's not very easy to embed the inputs. It's more preferred to add them through a panel or through a number slider. But here, I can just click on the numbers after this to change them. So if I want a radius 3 instead of 4, it is much quicker. If I do something in this fashion in which I create like a number constant and I write the number as 3 here, and then I connect it to this one, perfectly all right. It gives us the same result. The circle is exactly the same. It is just that if I write the number directly here, we are a bit faster. But if you want it to be a parametric component, then we can definitely add like a range or a number slider if we want it to be varied. But let's start with a simple approach where we can directly add the number here. And also with the point, I'm not required to create a center point for the circle. I can just write the coordinates x, y, and z in the options here. So x, y, and z coordinate. I'm right now creating this bottom circle, so it has to be on the 0, 0, 0 axis. So no change required here. Great. So I have the bottom one. Now let's create the top one. And let's assume the height of everything will be like 7 times higher than this one. So if the radius is 3, then we can do a 21 thing. I can copy and paste by simple Control C, Control V, any element, or I can take a new element again by following the process of double clicking on the canvas and then typing what I am trying to get. The other way to input is to go through the panels on the top. If you do not remember the name of any particular component, let's say this is a circle, it is in the tools. We are talking about primitive curves, basic curves, and I can see the circle here. All of this will result in exactly the same thing. Just you have many options on, and it's based on like what you find suitable, how your workflow is. So bottom and top circle, the radius, the size is exactly the same as I see in this geometry as well. It is just that it is, rather than being located on the ground level, it is on a higher plane. And how can I define a higher plane? I can simply, the radius is already 3, I can simply change the z point to a positive higher number. And if I do that, I see that, okay, this number, this circle is now placed here. If I just like play around with a bit, if I put 10 here, then it will be at the positive 10. And if I do 20, it will be at a higher level, and so on. Let us go with 21 at the moment. So I need 3 circles. I have the top one and the bottom one. And let's get now the tricky one, which is the center. We already know that the center circle will be slightly bigger. So to have a slightly bigger circle, what I should do, the simplest method is to just increase the radius of the circle. Let's try to do that. I'm copying the circle, which is at the very bottom. And then you can see that when I click this, the yellow thing appears here, which means the circle is located here. We already agreed that we need a larger circle, so its radius should be higher. So let me increase the radius to 5 from 3 to make it a bit bigger. And I can see that there is a larger circle now. But what we see that the circle is not here. It's somewhere in between the top and the bottom circle. It's at 0 z point. This is at 21 z point. So let's take 10 or 11 to get the middle point. And to change the location of the circle, what I have to do, simply just in the origin, change the value here. So remember, if you wanted to change the location of your circle, change the origin point. If you wanted to change the size of your circle, change the radius. We used both of them now. Cool. I see 3 circles aligned vertically, stacked vertically one on top of one another, and the center one being a slightly bigger circle than the other 2. So what condition I am now? I'm in this blue condition now, that where I have 2 circles on the top and bottom of the same size, and then there is another third circle in the center, slightly bigger. But we already established that we do not want to have the center circle to be parallel to the top and bottom one, but rather it should be like slightly tilted. And to get this kind of an effect, not like just like a clear bulging effect. For example, we do not want a situation which is like this, in which it is just bulging equally on the sides, but we want something like this. So how to rotate the center circle? Simple. If we want to rotate, it is intuitive. Let's take the rotate command. And our target will be now to just provide all the input for the rotation. The geometry we want to rotate, it's certainly the center circle. So let's add the geometry to the geometry. Angle. This is one thing to remember, that the input for all the components, wherever an angle is required in BeeGraphy, is by default in radians. I am personally, if you are familiar with radians, you can directly change the values here. But I am particularly more familiar with the degree convention. So there is already a command which says degree to radian, DEG to RAD. So I can just use this command and then add here. And then I can just choose the value here. Just as a placeholder, let me put 45 degrees for now. Okay, now I have to put center. At what point I would like to rotate this? What is the axis of rotation? If we go back to our small ugly design, we can see that we want to rotate our central circle. And this means that what we want to rotate is along this point, the yellow point, which is, let's say, the centroid or the center point of this blue circle here. But I do not know what is the centroid of this blue circle. I just have a circle right now. So to get a centroid, again, very intuitive, very simple. I need a centroid, so I just type centroid, get the centroid option. I put the circle into it, and then I get the centroid, which is this yellow point, which is exactly the same yellow point which we are expecting to rotate our design at. And then I create the center point to the center here. And now I finally have to provide which axis we want to rotate it to. And this we can do clearly by providing a vector here, whether it's the x-axis, y-axis, or the z-axis. So you see it is like right now rotating along the z-axis. Rotation along z-axis, what does it mean? Let me just show you here. Now this is the top view. If you look from the top, this is our circle already. This is our yellow point, which is the center. Rotation along z-axis means it is getting rotated. So my circle is getting rotated, but I do not see any change here because it is along the z-axis. So where we need to rotate it along the x-axis or the y-axis to see it visually similar to what we are trying to achieve. So let's try rotating it along the y-axis. And to do that, again, simple. I need not to create any vector. The vector is already here. So I can simply put z-axis to 0, and I can add 1 to the y-axis. Now you see that this yellow circle is the rotated form. I already have a circle which is rotated along the y-axis. Let's quickly check what will happen if it is rotated along the x-axis. It will be along the x-axis now. So very simple. You can play around. You can have a mixture of x and y, whatever you feel comfortable in. So let me just go back to y. I like it in this way. And I already have the circle. So it was pretty quick to achieve this form in which I have the top right circle, the rotated circle bigger here, and the bottom circle. If I just switch off the visualization of this here, like simply clicking on the 3 dots and then selecting hide, the component still exists. I am just not seeing it. So if I hide this point as well, I now get a form which is pretty similar to what I intended to achieve in the first place. Great. Our first step is fully done. Now, what was our next step? Our next step was to create like a smooth boundary around them. You see the new yellow thing which I'm adding, that we now somehow have to connect them as a surface rather than being individual circles. The immediate thing to do is to use a command known as loft surface. And now we simply have to add 1, 2, 3 curves in it and then see what happens. It is important that the order of the curve that goes inside the loft is maintained. So either go from top to down or bottom to top, but in the correct order. So it's like a more clean way to do it is to use this component known as merge. So merge combines all the data streams, the data coming from these 3 curves, and then it will be lofted together. So I'm going from, this is my bottom one, so I'm going from bottom to top. So I add the first curve here, the second curve, which is the middle one, by pressing the shift key, and then finally the third curve here. And then if I add it to the loft command, I see something happens. But I realize it is not what I intended to achieve. It is not looking like this. Because what is happening right now, if I just draw a quick sketch again, I have one circle here, I have second circle here, and I have third circle here. If you just see this geometry, this is what our situation is. And now lofting the 3 of them, it is combining the extreme ends of the three together in something like this. This bulging thing, which is shown in the blue dashed line, is not happening. So how we can achieve this bulging thing? If we can add one more circle here and another circle here, then what will happen is it will try to achieve, now follow my pink line, it will now try to follow the outer points of all of these 5 circles instead of just the 3 circles. So hopefully, if we do this by adding these two circles here, the one which is this, the other which is this, we are able to get closer to the form here. So let's try that, if it happens or not. One thing is, let's give it a slight thought whether we want to add a circle or an ellipse here. You might be wondering why the ellipse is coming into picture. If you just see that this circle is actually like a tilted circle or like a rotated circle. So what happens if, let's say this is my circle, if I rotate it, it will be rotated like this. So its width is getting reduced. The pink line, you see that I'm getting like a gap here after rotation. If I just show it on the top view, what I mean by this is if, and this is the top view now, if this is the circle, I'm now drawing the rotated circle with the red. This will be the rotated circle. But I do not want this. I want like the red will be the rotated circle. But I do not want this. We want that the circle to be precisely a cylinder in the top part and the bottom part. So how we can solve it? How about if I use an ellipse instead of a circle? So let's say in the plan view before rotation, it looks something like this. The red you see. So what will happen? After rotation, it will give me like a perfect circle here. Going to this drawing again on the left, we wanted to have the cylinder. This is the circle on the top. If I have an ellipse here, which is slightly bigger in this side, after rotation, I will get an ellipse which is having the same dimension as my circle on the top. So this is because of we are rotating it. It is better to go with an ellipse, and then we can get like a perfect cylinder. You can try it with circle as well, give it like a hit and trial, and then see whether you like that feel, that appeal of the circle. Otherwise, go with an ellipse. And for if I want an ellipse, what I will do, I just have to type an ellipse. Okay. Right now, I cannot see where my ellipse is coming because I have this lofted surface here. So to hide it, we can quickly go to the lofted surface and press hide. And then the things become much more cleaner again. Okay, my ellipse is here. I want it to be somewhere here, ellipse. I know that this was my center point, which is 10. I used it for this circle. So I have to go higher than this. So I can just put the origin is the z-axis 13, 14. I can't decide, so let me put 13 and a half. Now I see the circle is too big. What I want, that in this direction, the width remains the same as 3. And in this direction, the width is a bit higher, so that after rotation, in the plan view, it start looking like a circle again. So what I can do, I can change the radius. I change the radius to 3, which is the same radius as the radius on the top. And is this direction slightly higher? So let me go with 3.5. Perfect. So now I have an ellipse here, but it is not rotated yet. I need to rotate it exactly the same way as the circle in the center. We have to follow the same approach that I followed here for the center circle. We use the component known as rotate. Simple. Rotate geometry goes to geometry. To rotate around a certain axis, I need the center. Again, centroid, curve geometry, centroid, and the point goes there. I have the center here now. I do not want to see this point, so I just hide it. And how much I want to rotate it, it's exactly the same as this one. So I can directly connect the same input, which I create, the radian input, which I created for the center circle, to attach here as well. I see it doesn't seems to be rotating around. It's again the same thing that we need to decide the axis where it is rotating. By default, it is along the z-axis. I put the z to 0. We want it along the y because we did the same in the center one. And I put the 1 to y. It looks a bit messy. If I just hide it, I can see clearly that, okay, now it is more or less the same size and it is getting sliced properly. But I think that this angle is very strong right now. I need like a slightly lesser rotation. So I can change the angle here to 30 degrees and then let's see what happens. But visually, it looks pretty fine to me at the moment. But this is all not done. It is just we got the cylinder in the top half right now. We need a cylinder like a continuous flow in the bottom half as well. So what we do, I can copy the ellipse. Yes, I can just see it. It is exactly the same ellipse, but I do not want it so high. I want it now lower than our central circle. The center circle, you remember, was at z location 10. So to get it a bit down, I can, the z location is 7, a bit lower than this. And mind that it is like parametric design. So these numbers are can be changed easily. You do not have to start the form again. That is the biggest perk, that is the biggest benefit we get out of parametric design. Just we have to simply change the number and we get like a new form out of it. Cool. And again, I have the now circle parallel to the to my bottom circle, but we do not want it to be this way. We want it to be parallel to our middle circle to create a cylinder here. Follow the same methodology. I'm copying the rotate component here. The geometry is the geometry, which is our new ellipse. The centroid I need to find out for this new circle. So I add the component centroid, pass the curve through it, and then put the centroid in the center. The angle remains the same. So all three of them are getting rotated by the same thing. Let me hide it. I do not want to see the centroid as well. And now we have like 5 circles here. Exactly the 5 red lines that we wanted to have. And the good part is, if I change the angle here, all the 3 angles get changed together, which is pretty helpful for me. Okay, now let's add all of these 5 things to the loft and then see what happens, whether I'm able to achieve the geometry I imagine or no. If you remember, few minutes ago, I told that it is imperative to go sequentially in assigning the surfaces, assigning the curves. So you can either go top to bottom or bottom to top, but they have to be in series. I cannot insert this circle in between the already merged list. So I start in providing all the data right from the beginning. Again, going from bottom to top. So this is my extreme bottom ellipse. This is my ellipse right on top of it. So keep pressing the shift key and add it to the list. This is my ellipse. This is my circle, central circle, the biggest one. Keep pressing shift, add it. Now I want this ellipse, which is this one precisely. Yes. And now the top circle, which is not this, but the one at the bottom in my case. And this. So it doesn't matter where the stuff is located on your canvas, just the order of providing the input to the merge list needs to be taken care properly. I see the list. Yes, there are 5 input there. And now I switch on the visualization of the loft surface. If I zoom in, yes, it looks pretty cool. This is the kind of stuff I imagined to achieve. Yes, very similar. To get it more clear, I am just hiding all the circles so I can concentrate in visualizing the surface that is created out of these 5 basic circles. So you can like multi-select different components and then just hide them. So everything will be hidden together. If I change the angles, let's say from 30 to 35, okay, perfect. Change the bit, everything, and it looks good. Let's say if I want it to be a bit taller, I can just change my top circle height a bit. So right now it is at 21. Let me make it 24. It's higher. Great. I like it even better now. So let us go ahead with this. So it's just that, again, I'm repeating myself, but it is very important to understand parametric design is about parameters, and you are allowed to change parameters anytime during the workflow. So it's not like a very creating of an algorithm is a linear process, but modifying the geometry, modifying the form out of it is based on how you want to achieve it. So I like this one better now. So I just go ahead with it. And it is not yet that I have finalized this one. I'm just writing a script right now. And after 10 minutes, I maybe come back to this and then change some parameters again. But I do not have to write the script again. I'm just changing few parameters and I'm getting a new form out of it. Perfect. So this was the most tricky and let's say parametrically intensive part to identify what exactly we are doing. And it's very interesting to see that just with like basic primary geometry like circle, we are able to get this parametric form. Perfect. Now I want to create like these kind of a finned structure to it, which has a width to it. I do not want like a surface. I want these individual panels rotating around. For this, I need like a thickness, how thick I want these panels to be. If I want to add thickness, what command we can use? Side thickness. No points for guessing this one because now, as you know, BeeGraphy, very intuitive. Whatever you want to achieve, just try to type it out and there is a very high probability that you will get a component which does exactly the same thing. So what kind of input needs to be provided? It just needs a surface and a thickness, how thick I want it to be. So it converts surface into like a solid of a particular thickness. Right now the solid thickness is 2, the surface is surface input. Let me just provide the surface and then see what happens. I hide this one. It is extremely thick. I have no space in my geometry. So I want it to be thinner, but I want that the mass, the thickness which is being added, it should not be added inside the geometrical surface, but rather outside. What we can do, it's simple. Rather than having a plus dimension, let's add a minus in front of it. So rather than +2, if I do a -2, what happens? Now the whole thickness addition goes to outside, but it is super thick for my taste right now. It just doesn't look like aesthetically pleasing to me. Let me reduce the thickness here. Much better, but I would like it to be even slightly thinner, let me go with, let's say, 0.75 minus 0.75. Perfect. I like this much. So you see, in just like 20, 30 minutes, we are able to get this solid geometry, which looks pretty cool and similar. But at the end of the day, what we are creating is a light fixture. This is a solid. There is no gaps for the light to come out from this one. So I need like openings here and just like thin slits rotating around. And how we can do that? For that, we will use, there are thousands of ways to do it, thousands of permutations and combination, but we probably are going to go with something related to, let's say, solid interaction, solid intersection, and then create these individual slits. So how does a solid intersection works? Let us see on this canvas itself. If I have a solid cuboid, and then I have another solid cuboid with some part where they are overlapping, the place where they are overlapping will be the result of the solid interaction. So intersection. So what is happening? That I provide two solid as an input, and then we intersect them, and whatever is the common solid between these two will be given as the output. I already have one solid, and now you can see properly in the action what I meant by reverse compatibility. That, for example, there is a canvas and there are a lot of geometries going. I want to see which component was leading to that geometry. I can simply select this in my my visualization, 3D visualization window. And as soon as I click on it, I get the component highlighted, which is leading to this. So then it gets like a complicated large script, very helpful to get oriented and sort things out. Great. I have my first geometry, first solid here. So what we want to do, we said that we want to do a solid intersection to do that, where I can find the solid intersection. In tools, there is already a lot of Boolean operations, and then there is this thing known as a solid intersection. Perfect. Otherwise, I would have just written solid intersection, and I would have gotten the same thing as well. So for solid intersection, I have my first solid, correct, but I do not have these fins. So I need to create these fins. How about we create like a plain rectangular slits around, like rotated around the geometry, and then we use them. Let me show you what I mean by them. Let's create like a plywood panel with some thickness, like a solid cuboid, like a box. So let's create like a box kind of a thing. Yeah, box. But this is not the ideal box. There are other ways to create a box. Yes, I can create a box by 2 points. Perfect. So I need a box which is at least the height and which is intersecting. So what I mean, let me show you again. That let's say I already have this solid geometry. It doesn't look like what we have, but just imagine that it's the same thing, the red geometry. What I want to do, I want to create like a cuboidal box here. And when we intersect them, then what will be the result? It will be the result like one panel of lighting for me. So like a one singular panel. And then I can just like copy the singular split in rotate them around, copy them in a circular fashion, and then I think hopefully I will be able to achieve it. So let's give it a try. So if I see here, I need the box which is completely covering from the center part till the extreme uh, corner in height and in the width of my lofted solid, which is the one in violet color. So let's just change the points. I do not want it to start very center, so I just type, let's say 0.2. So we just get away from center a bit. And the width could be about the thickness, how thick I want the stuff to be. And I have to make it a bit down. So let's do this. And here as well, width of 10. Yeah, this covers everything. So 10 is okay. And here I can just increase the height. Now, yeah, it looks pretty good. So what were our parameters? This is exactly the same thing which we were trying to achieve here. But I need to create like a solid box. And this is just one way of creating a solid box. You can create like a rectangle and then extrude it. You can define multiple points. You can define a bottom surface and then extrude it vertically the way you like it. The thing to remember is that we need to make sure that all the inputs are properly done. So yeah, this looks good. I have a solid box. If I intersect them, let's see what happens. The Boolean operations are pretty computationally intensive, so it takes some time. Let me hide them. And then let's see what happens. It is the reverse thing that happened. I actually wanted this slight thing to remain, but it created the other one. So what we will do, we will just like shift we can change the solid 1 and solid 2. To remind you that solid functionalities are pretty computationally intensive. So use them wisely. Do not change them. Okay, something is not going as expected. Then, okay, let's keep on creating our stuff. And then let's see what happens in the very end. In the meantime, I can just disable this component so that it doesn't take our computation power. What is happening right now is there is only one panel. We want that it should be there all around. So how we can do that? There is something known as a polar array. Polar array just means that I have one element, and a typical linear array is that I can create like a linear line out of it, as you see here. A 2D array is that the same line is happening in a 2-axis. And in polar array, what happens is that I define a center point, and along this, the items are rotated. And this is exactly what we want to achieve as well. That we want to have a center point, and along this, the elements to be rotated. So we want this rectangular sheet to be rotated around. Then let's do polar array. I want the box to be moved, and perfect. This is what I expected, that it is rotating all around. And we can just directly set the count here, how many boxes we want. Let's say I want to have 25 boxes. So let's say I want to have these 25 slits around. You can change how dense you want, how much light you want how much light you want it to be coming out. But yeah, pretty much sorted. I have a polar array working well. And then let us do solid intersection. Again, let's try if it happens this time. And this is the geometry. So I want my central solid to be intersected with all of these panels, and the resultant should be our panel creation. It's going to take a couple of minutes, like a minute or so. So I stop sharing the screen. We are towards the end of this session. As soon as this is done, we will be okay. So if you have any questions, you can open your microphone as well. Otherwise, the chat is always there. I think everything was super clear for everyone, and there are no questions.
You guys can share your question on the chat message as well. So great, Ayush. I think we have concluded the first session of this
Just
workshop.
give me a minute. I just show you the final result, what we are able to achieve with this one. Yeah, and we will have our next session in 10 minutes at 1:15 GMT. So just calculate based on your local time what the thing is happening, and then we will learn to create a drone in that session. And let me quickly share the screen before we go out. That this, you already saw the glimpse of it, but just again quickly, that this will be the thing which we will be creating in our third session about urban form. So stay till the very end, and we will finish our day with recreating this thing.
So I will take a 10-minute break, I think.
Yes, yes.
But we are here, so you can
in the
ask
meantime,
any question in this 10
exactly.
minutes. Yeah. So you guys, those who want to take a break, they can quickly have their 10-minute snack.
Think about it. Try to just play around with all the tools. Do not follow exactly the same steps which I did. This is just a guide. The computational design is about expressing yourself in the way you find it most convenient. Just try different elements and try to achieve the same result. And if you find any troubles in between, we are there to get them sorted as well. But just play around, get your hands dirty, and just try to be there in the interface for some time, and you will get there for sure. Perfect. So now we just have 8 minutes left, and see you there in some time.
Yeah, so Daniel wants to ask something.
Hello. Good morning.
Hello.
Thank you for doing this presentation. This is my first time using BeeGraphy, and I was trying to follow along with the LAMP tutorial, and you were saying that there's a lot of computational power. As you were saying that it crashed on my end, and I'm trying to open it up again, and unfortunately I'm not able to.
You just have to reload it and just wait. So that is a good part and a bad part. The good part is none of your local computation power is being used to do that. It is happening on the browser completely. And the second good part is that everything, whatever you do, is getting saved instantaneously. So none of your progress is being lost. So for me personally, I have come across many scenarios in Grasshopper. When I created something, I just was not able to, I just did not, let's say, properly manage the list. The computation got super heavy and I lost a lot of progress. So the best part, you will not lose any of your progress. Whatever you did will always stay. You just reload it and you will find yourself in the exact same spot where you left.
Daniel, just a quick question, since as Ayush mentioned, it's the computations are done locally in your browser. Can you share the specifications, like what's the CPU RAM you have? I'm curious whether, or maybe you have a lot of tabs open. Maybe you, like, if you
Oh,
close some of the tabs, it will help you.
maybe. I'm not running this on a powerful computer at all. This is I'm running this on a pretty old Microsoft Surface. I think one of the first models. I think I'm lucky if maybe there's 4 gigs of RAM on this thing. So we're working with a little bit of a limitation here. Yeah, but so it might take me a little while before I get back up on this.
Then spend some time and let's see if after our break it gets resolved or not. If not, then maybe Learning can have a look again if everything technically is right or wrong.
Yeah.
One thing Ayush already also noted, that you can achieve the same thing where different algorithms, scripts, and for this one, Ayush, you used lofting and booleans afterwards, like both lofting and booleans,
Booleans are heavy components.
heavy computationally. So Ayush, like I'm definitely have a lot less experience than you, but why didn't you use like a divide by count and then lofting somehow, like, instead of, you could do that, right?
No, for us, like the target is that in our overall workshop series, we have to introduce all our participants to all the components that exist there, like the whole length and breadth of BeeGraphy.
Mhm.
So it is much easier and much more prudent that we use these components when we are doing like small forms like lamp and all, rather than large forms like facade and everything. We do not want to skip any of them. Like everybody should be aware of what all are the possibilities. So maybe it's a good challenge for Daniel to try to achieve the same form, but in a much less computationally aggressive format. So just give it a try if you are able to achieve it in a different way.
Also try to achieve it using simpler computations.
Yes, without using any solid Boolean. And then there are, I must tell you, there are at least 10 different ways. Learning already gave you a hint about what is the one possible option, but that is not the only way around. There are many other ways as well.
So this will be my challenge to think about for the rest.
This is your homework, let's say.
All right, will do.
Perfect.
So anyone else has any question?
Daniel, if I'm not mistaken, you're also on our Discord.
No, I'm not on the Discord. I'm sorry that I didn't respond to your. I think you emailed me earlier in the week, Nick. Right? I'm sorry.
Okay, because I remembered your name.
Yeah, sorry for not responding. I just I was reading. I got really busy. But I saw you were pointing me to some of like the entries, and I was gonna take a look at some of those today. You know, just I've been brainstorming a little bit to what I might be able to do with the software.
Okay. The reason I mentioned Discord, well, if you're not there, you may use it to ask questions. Our team members would answer the questions, like if you need advice on how to do this or that algorithm, like share the design, maybe ask some advice from our team or from the community. There are a couple of active people that are also on this call. I mean, outside of our team. Maybe I take a time, Lars, to thank you for being so active and helping the community in general.
Of course, I find that I always find like I guess new ways to express yourself. I guess creatively are always you know it's always something that's worthwhile to at least look at, or you know it's I always like challenging myself, learning new things. So you know this is a good opportunity for me, I think.
Good. Anyone else
Perfect.
having any questions? Like, well, maybe you can share some feedback in the chat box. Like, was everything clear, or like, is the pace good enough, or you want it slowly or faster?
We are also launching some polls and within the workshop. So anyone who wants to take a break and wants to share their opinion, thoughts in the poll section, so they can go there, vote on the ongoing polls. Anyone has any question about the competition part? I'm happy to answer that as well.
Do you guys host all the computations like on your end? I'm wondering if like you guys worry that you know, if maybe like a lot of people are doing computations at once, that it would overload the site or overload the software because you know it's being processed online and not locally.
No, it's being processed actually. The computation is done locally on your computers. So what BeeGraphy stores is the algorithm itself, and we are synchronizing. So what you're doing locally is in sync with the storage, but it's only on the algorithm side. The computation and the rendering is done on the client side. That's why it's not working on your Surface, for example. Like if it's an older device, you may have issues there. But at the same time, that allows us to make it accessible, because if we handled all of the computations on our service, we would have to have a lot of cost, and then we would probably be unable to make it free.
Lanny,
So-
are you? Sorry,
Sorry.
Daniel, go ahead.
Sorry, I was just gonna say like, oh, that's how you're able to like I guess save it instantaneously. I was wondering about that.
I didn't get it. What was it, a question?
No, it wasn't a question. I was just making an observation.
Okay.
Lanny, I was asking whether you have any like future plans to also offer like cloud computing to some premium paid customers. They can, rather than running everything locally, it can be done on a cloud for those who do not have a strong machine.
Yeah, probably as a paid feature.
Yeah.
That's something we could add in the future to reduce the load on the local computer. We can do the computationally heavy part. As a minimum, we can do the rendering part,
Mhm.
because in most cases, rendering is what takes most of the computational power. We can do it on the server side. Apart from rendering, I think only it's a few computationally heavy operations like Boolean operations that are heavy.
Mhm, mhm.
The rest are not that bad.
Okay. Perfect. Shall we start the second session, or we wait more? Let's start in a couple of minutes at 20 past the local time. Divya, let's start with the second session.
Yep.
I'll share my screen. Is it visible to everyone?
Yes.
Okay, great. So hi everyone, I'm Divya. Last time I took the arts and collectibles session. We'll continue with a newer section of the awards. It's called DIY and Engineering with BeeGraphy. So here we'll try to understand what is the intent of this particular section of the workshop, existing references, design and logic building towards it, and then exploring the design on BeeGraphy, modeling of the design. Can try exploring materials, configurator, collaboration modes, exporting 3D printing, and then the challenge. So the brief of that particular section is that we have to develop products. It could be anything that is a unit or a assembly of smaller units, and it needs to probably have a purpose, what it has been made for. It needs to have it needs to be like fabricated, laser cut, 3D printed, any technology that can be incorporated. It needs to be assembled into a final product. So examples can be a drone frame, or it can be DIY toys. It can be practical everyday products, and it should use computational design and digital fabrication through BeeGraphy to achieve it. So one of the examples already provided on the website is one of the models available on the BeeGraphy marketplace. It's a drone assembly. So you have the body and the arms, and it's a laser cutting. It can be either 3D printed, or it could be used for laser cutting these parts and then assembling them together. But at the same time, we can also look at other different DIY projects like simple toys. We have the drone frame itself. Then we can have laser cut parts such as phone stands or small DIY objects for our curiosities. And then we can have stands such as for screens or fixtures in the house, and as well as we can use it for mold making purposes that we could use for other fabrication technologies like pottery or making of parts through molds. So all of that can also be utilized. So what we today would try to achieve is a drone assembly. We'll try to also keep it pretty simple. So a drone basically is, I think everyone is familiar with the setup, but I'll just go through it briefly. The drone generally has a body, which is the central part. It has arms, which are on four sides or more. And then it has these propeller units, which help it rise up above the ground. And then we need some power source for giving power to the whole assembly. So we have a battery, which is at the base. And then we have and then the drone can be used for multiple purposes. In this purpose, it is attached, a camera is attached on the top. So it would have that kind of a housing. And then it would require some
Yeah.
antenna. Yeah.
Sorry to interrupt. I guess you're sharing something, but we don't.
Oh.
Okay, now something happened.
Is
We
this
didn't.
visible?
We just saw the first screen, and nothing changed until now. Yeah, we were
Okay.
just this one.
Okay.
until-
Sorry. Should I go through that again? Yeah. So is it visible now?
Yes.
Yeah, it is
Yeah.
now.
Oh yeah, the slideshow.
Sorry. So yeah, BeeGraphy. So it's DIY and engineering, and then overall workflow. I've already explained this. And then yeah, basic brief for the section, making a product, which can be 3D printed, laser cut, fabricated. Intent needs to be a DIY object. It could be used for any productive purpose, and then it needs to be an assembly of units, or it could be a unit itself. And then examples would be drone frame, DIY toys, practical everyday objects, and it should use computation design and digital fabrication techniques. Then one of the examples provided on the website itself is this drone frame. It can be 3D printed or it could be laser cut as well. But there are other examples as well, like toys, drone frames, and then we could have phone stands, small laser cut objects, some stands for tablets or any fixtures that could be utilized in the house. And then we can use it for molds and molds for construction, to be used for other fabrication technologies like pottery or lost wax casting or something like that. So then what today we'll be exploring is a drone setup. I'll take everyone again through the parts. So everyone is familiar with the object. It has a body in the middle, and it has arms on four corners. And these arms are then attached to a propeller unit. The propeller's function is to raise it up by rotating. So it requires a power source. The power source is provided by a battery. Most drones have camera units, but they could add additional functions to the drones. So in this, we can see there's a camera unit, and we have an antenna which would link to the control unit in our hands. So that's the general assembly. Today, what we can try is making the body of it, because most of the other elements could be assembled, or most of the other body elements could be researched and procured from the market and then attached to the body. So general DIY process is quite linear, but then it goes into a feedback loop after a while. We have an intent. The intent is translated into research. So research could be about how drones work themselves, how the configuration of each of the wings happen, how do the wings get controlled individually if the drone has to move from one side to the other. So once we have that research in our head, then we can go towards procuring systems and parts. So then we'll divide the drone into smaller systems and parts, and then we'll go ahead looking for those parts in the market. So most parts, such as the chip that programs the whole thing, or the battery, or the propeller unit, or the motors of the propeller unit, all of them could be procured in the market. And then after that research is done, it can help us in modeling, because each of these units come with each of these would come with certain connector dimensions. So this one has screws, and this could be attached through screws or nuts. So we need to understand what the sizes of those are. So once market research is done, it can help us in modeling. And once we have modeled, we can then start fabricating. Now, after fabricating, we go back into a feedback loop where we go back. If we face some issues, we go back to the fabrication or we go back to the modeling. And then that loop continues until we have a refined product that is tested. So yeah, that's the general DIY workflow. Market research can easily be done online. You can find various websites which give you paths on a very, some of them can be very cheap to acquire, so we don't have to invest our time and money into modeling them or 3D printing them. And then we also have to look for these connector paths, which could be very useful because we already know what is feasible, and then we'll make connections accordingly. So today we'll try to attempt the drone body. And as you can see, there's a central body and there are 4 arms on each corner. So I'll take us to the whiteboard. Is the whiteboard visible?
Yes.
Yeah, okay.
I see it.
Okay, so I'll start. So we need to break this form down into parts that we can then fabricate. So the first part that I see when I see this geometry is that we require a squarish body, which is the center part, and then we require arms coming out of the squarish body on either corners, on all the corners. And then we can use operations such as solid union to join them all together so that they become a single body part. As we see here, I think we can start with that. And then once we have this kind of a curve developed on the base, then we can extrude that particular curve in the z direction to generate the body. And then we can understand how we can go about making the housing for the chip and the battery. So I'll go to my BeeGraphy thing, BeeGraphy page. I'll enter into my modeling space. So I've already made a model. People who are starting out can create a new model here. You can name it as you wish. And then if you want to collaborate with people, then you can share that particular file, and you can write in that person's name and what kind of access you want to give them. So this could be very helpful for collaborative projects. I'll go into the space. I already have a script in place, but I'll start afresh. Just a second. I think it. Yeah. So let's start with making the body first. So for the body, we'll start with a rectangle or a square. So I'll just use the rectangle tool, but I'll use the center one because I wanted to start from the building it from the center, which is the origin point on the grid. The size of it, I would want it to be, so once we have done a market research, we know that the battery comes in a particular, sorry, the chip of the drone comes in a particular size. We can, for now, say it is around 40 millimeters by 40 millimeters or 4 centimeters approximately. So I'll write 40, and that would be, I'll just go with a range input so that we can use it for the configurator mode. I'll write chip housing. So chip housing dimension, and this will go into this and this. Now, this is the size we require for the chipset, and we'll then make a frame out of it, which is slightly larger than this. So we have made a rectangle. We can try making another rectangle, which is slightly larger. So here I would try to make it parametric. So say I want the frame width to be around 10 millimeters or 1 centimeter. So I'll use a range input. I can rename it to, or we can just say body frame. And then what I will do is I will add this frame to the chip housing to generate a slightly larger rectangle. So basically I have an inner one, and then I want some distance of that housing from the edge of the body so that we have some stiffness in those areas. So this is where the chip will house, and this is the frame of it. Now we want to develop the parts where the arms will attach. So these parts where the arms will go and attach the body. So for that, I will first. So this particular geometry has been generated from the origin point, which is in the middle here. Now, for making something in the in a rotated plane, we would require this origin point or that plane to be rotated. We want it at the corners, and a square's corners are at 45. So we'll just rotate the plane. So I'll use rotate plane, and the plane we want to rotate is the origin, which is the XY. So I'll just make a XY plane. I can put that in all the rectangles. It would give the same output. So as you can see, the plane has rotated, and the plane can then give us these directions, which are going towards the corners. How do we get those directions? Is we can deconstruct the plane. And what deconstruction means is that it can break down the plane, and it can give us the origin point, the x, y, and z vectors of those planes. So that could be very useful when we are making things in that diagonal arm. So let's make those attachment paths. So I'll just go again, type for rectangle. I'll go with a simple rectangle. The origin point would be the new point here. Sorry, it will be the plane, so that the rectangle is being constructed at an angle to the other to the existing body, and then we can give it a length and a width so that it goes outside the body. For that, I can for the length I can go for, say, 50 or 5 centimeters. So this I will write as the body arm length, and then we can give it a width also. So if I click on this part and I press Alt or Option, it can duplicate it, and then I can change this to width, and I'll make this as 30. So this will go here, and this will go here. Yeah. So we have a rectangle, but it is not centered at the corner. So we would have to move this rectangle towards the center. So for that, I will use move, this geometry, and then I will use vector. So the direction I would want to move it is this direction, so that we can get through the deconstructed plane. And we would also have to tell it how much it has to move by. So I'll use amplitude for that. So amplitude vector, the vector we can, which line it is? I think it might be the x direction. So I'll plug this vector in, and I'll give it an amplitude, which would be basically half my width. So my width was 30. So I'll use division, and I will divide my width by 2. Because I want to make it parametric, I won't be manually putting in the parameters every time. Oh, it was the y direction. Yeah. So if I preview of, oh, so this has gone further. So we need to give it an opposite vector. I'll use opposite to change my positive number to negative number. And then we can see it is now in the center. Great. I think we can. So we have this particular house. We have this particular arm. Now we can rotate this arm around so that we have 4 of them attached to the body. So I'll hide this, and I will use polar array. And by default, the count is 4, and the degrees are, the angle is 360 degrees. So it would by default do what we expect it to do. So I won't be changing that, but we can always introduce or increase the number here. Point is the center point. Again, by default, that is the 0, 0 coordinate. So I won't have to change that. Vector and angle is it's in radians right now. That's why it's written 6. Okay. So we have the body and we have the arms. So maybe I can increase the body size a bit. I can go with, say, 50, so that it's slightly outside. And let's try to merge all of these shapes together. So I'll introduce a component. It's called union region. We can use this to merge multiple closed curves. So if I put all of these geometries in here, and I will put my body frame. Okay, sorry, wrong frame. Yeah, I'll put this outer frame along with my arms. I can see it has done something, but I think so our inputs are in 2 different branches, and we would want them to be in a single branch for the function to perform properly. So we would have to flatten the input first. So I'll use flatten tree for that. I can press shift and control to plug all the data into flatten, and then send it to the input. So I'll preview of this whole previous part. So as you can see, we have a body now. Outline of a body now. We can make it a bit smoother. I guess we can use. We had fillet in this, but we can also try chamfer. So I'll just use chamfer curve. I'll put in curve, and you can see it is asking for two inputs for the chamfering. So we can go with say 5 millimeters range input. I'll change the name of it to body chamfer. I'll plug this in to both of the inputs, and I'll preview of the previous part. So we have the outline of the body with us. We just need to extrude this. So if we extrude it without making it into a surface, then we will only have the outer walls. I can show you that. Extrude curve. So when I do this, I only have the outer walls. I don't have the base. But we can use capping for making it into a solid. So let's go ahead with this only. I will just copy the previous slider. I will change this to body height, and I'll plug this in. Oh, it needs to be a vector, sorry. So we'll introduce a Z vector, plug in there and put that here. So we have, and we can increase this to, say, can go with 40. Oh, this doesn't go all the way there. So we can increase the maximum it can go to. I'll put in 50, and then I can change it to 40. Yeah. So I have some frame. Maybe we can go with 30. Yeah. So we have the body ready. We can use cap tool to convert the open polysurface into a closed polysurface. Cap just closes all the planar cutouts, and yeah, we have the body ready. Preview off now. Okay, so we have something closer to what we have here, but then you can see there are parts which are subtracted from this geometry. So the first part is we require a housing for the chip on the top, and then we require a housing for the battery on the bottom. So we can start with, I think, the chip first. So we require, again, we'll go with solid operations. So we are required to make a rectangle above here, and then we'll subtract the rectangle from the body. So if I go back, I already have that rectangle ready. It's on the base. Now I would like to move this up to this part because I want to subtract it from the top. So I'll use move. And then I will give it a direction, which is Z. And we already have a height for the body. So I'll just move this component ahead. We already have a height for the body, which was this one. So, and it already has a Z vector, so we might not even require it to be given. So our rectangle has moved up. Maybe we can give it a fillet so that it's a bit smoother. Fillet geometry. I'll put this in, and then I can give it a radius. So I can give it, say, 5. I'll go with a range only. So this would be chip housing fillet. I'll put this here, and I'll preview of the previous one. So as you can see, we have a outline for the housing. Now we would want to develop a solid here, and then subtract it from the base. So for that, I will extrude this geometry down. The first thing I'll do is I'll convert this curve into a surface. So for that, we can just write curve to surface, and it will convert our curve into a surface. And then we will extrude the surface so that we already have a solid right away. It has to be extruded in the opposite direction. So we'll give it a Z vector, and then we will give it an opposite. And then we will give it a depth. So this would be chip housing depth, and I'll put this in here. So if I click on this, might not be visible. I can preview this off for now. Yeah, so we have an object which is going down, extruding down. And now we'll subtract this this object from the other object to get the difference. So I'll use solid. I think I'll just write difference, and we have solid difference. So solid difference, what we'll do is we will give it this first and then this. 0 level, 0 level. Maybe I'll try to swap these two and then preview of. Yeah, so we have a cavity there. I hope it is visible. The color is a bit dark. But yeah, there's a cavity, and then we can always increase the depth of the housing if we are required to, or decrease the depth. So that is where our chip will be stored. Okay, great. So now we can move on to the next part, which is the housing for the battery at the base. So now the battery also comes in multiple sizes. Its height could range. It could be two batteries together, or it could be a bunch of multiple batteries together, because the propeller can be a bit power hungry. So how do we make it? We'll again just use another rectangle at the base. So I'll go back to the origin point. I'll make a new rectangle. I'll make a new rectangle from the center. So this one, and I'll use the same plane, but I'll give different widths to it, because as we can see, it's more rectangular, so that it probably goes like that. So it's a bit more rectangular and long, probably because it's like phone battery, so it's a bit rectangular. So we can go with, say, 30 range input. This would be our battery width. Battery housing width. And then I'll copy this down, and I'll change this to housing length. This goes here, that goes there. I can then increase this to, say, 60, probably more, 100. so that it goes slightly outside of our drone body, so that I can subtract and have a cavity here. So for yeah, so I think this would work. And then what we can do is we can just extrude, or maybe we can just first make it into a surface. So curve to surface, and then we can extrude extrude this curve. Yeah, we can extrude this curve, extrude the surface. Extrude the surface, and we can give it a height. We want it in the Z direction, and then we can go with, say, it's 10 right now. We can keep it 10 only. So 10 range input, and we can change it to battery, housing, height. I'll put this in here. Great. So now we have that. And then if I take this forward, we can then Boolean. So again, Boolean difference. Just like difference. So solid difference, and then it looked like this one would go into this, and this one would go into this. And then I'll just preview of. I think it did the opposite. So I'll just use this and this. Okay, maybe I'll just move the plane a bit lower. Say by 1 millimeter. Would you guys know why this might be the case?
Try reloading the script once.
Okay. It was working previously.
Yeah, there might be some backend issue at the moment, so maybe we can just proceed, and because the concept is
Okay.
What is the problem?
It's just that there's two objects that I want to subtract, like solid difference,
Mhm.
and it's unable to do that. If I increase the height, would that affect? Like it's doing the other way.
Seems to be intersecting at least, I think.
Yeah, it is, but for some reason it's not.
Are there two geometries over there? Like
Maybe I'll.
blue and green?
Yeah, there are two geometries, blue and green.
Okay.
Seems to be not.
Can you
Maybe
turn off
I'll.
the blue one for a second?
Which one?
The blue geometry which is there. Can you turn it off and just try the intersection with green and the magenta one?
It's still not happening.
Interesting.
I'll look
Okay.
into it.
Okay, anyway, we'll have that base. I'll show it. There's a script already ready on the back. I'll probably show it later. Maybe we can move on to generating the arms. These ones. So let's go ahead. I'll go back to the whiteboard. So we have a base frame, and then we have the arms that go out. And then we would require some units to be attached to these arms on which the propellers would be resting or housed. So what we would want to do is develop those. So for that, I'll again use the origin point and I'll move it in the direction of the arm. So we'll try to develop one of the arms, and then we will polar array it on the other sides. So I'll go back to the origin point. I'll use move, and then I will use the deconstructed plane because that was the rotated plane to give it a direction. I'll use amplitude. The vector could be x, and I'll move, and we have to move it, say, we can go with, say, 100 as our length of the arm. So I'll change it to arm length. And we can see it has moved. Oh, geometry, we have not provided it yet. So it will be, it could be this origin also. So origin, yeah. So that is how far the arm will go. So we'll be making a triangular arm here. I'll move this a bit down. So the next thing we want is to make a triangular arm. We want these endpoints as well. So for that, maybe I can move this point again, but till this part. So for that, I will again just copy the same script by pressing Alt, but instead of giving it a manual direction, I can just give it the length of the arm that we have already made. So that would be body arm length, so 50. So I'll use this, and I'll plug this in at length. So as you can see, we have a point there now. So now what we would want to do is we would want this point to go till the end on either side. So maybe we can just move this geometry again, but right now we won't move it in the we would move it in the y direction because we were taking x right now. So I'll use amplitude again and plug this in here, and this time we will use 30, which was here, I think half of that, because we have to move on either directions. So that would be our length, and the vector would be we were using x, so this time it will be y. Yeah, so we can see it has moved in that direction, and we can do this again through opposite. So I'll just copy this and this, put the vector in, and then I can just use opposite. For the we can also, if we double click on a wire, we can convert it into a node that could then be used for connecting into other objects. So I'll put this in. So this could be very helpful if our inputs are a bit far away. So yeah, so we have these 2 points now, and then we have the point which we had on the other side. So now we can just use polyline tool to interpolate through them. I'll again use flatten tree just to be safe. Put the geometry here, put this one as well, and then put it in part. So Boolean, so polyline would ask you a Boolean component, which is either true or false, whether you want to make it into a closed polyline or not. So if I write Boolean, maybe I can write true. Yeah. So you have Boolean, and then we can change it to true or false by click on the button. And I'll just plug this in. We want it to be closed, so you can see that it has closed it now. Maybe we'll add a chamfer to this as well. So I'll chamfer the curve. And we'll use the same chamfer as we had previously. So I'll take this down. And I'll again double click on the wire to give me a node. And then I'll put this in here. Yeah, I'll hide the previous part. So we can see we have an arm now. Now what we want to do is give it a depth, give it a frame width as well as a depth. So we can just offset it. I'll write offset curve, put the curve in. We want it to offset in the negative direction, so opposite. And right now it's 2, or we can continue with 2. So I'll use a range input for this. Can write it to be arm width. No, so arm thickness, I think. Arm thickness, I'll put this in distance. So you can see it has gone in now. And then we can loft between these two. I'll use Latin again. And then put it in curve. So you can see it has made into a loft. And then I can extrude it. Or maybe I'll move it first. So I'll move this geometry because I want this frame to be triangular. I want this frame to be like this, slightly inclined at the bottom. So I'll just move this up to this height, and we already have that height at the back. If I go to body height, so this is that, and we already have a Z vector for this. So I'll just plug this in to my vector. Yeah, so we have this component there. Now we can extrude it downwards. So I'll use extrude curve, extrude surface. And then I'll give it a negative Z value. So Z opposite just go into vector, and then I'll give it, I guess the same value as the thickness we were giving here. But it already has an opposite, so I'll just use the same. Yeah. So we have the upper part ready. Now we need to connect it like that. Maybe I can increase the arm's length a bit more. It's very squished right now. So it's at 100 right now. I can increase it to say 300 and increase this to 120. Yeah, 120 seems fine. Maybe 125. Yeah. Okay. So we'll move on to the next part, which is making the inclined base. Also increase the thickness a bit more. Yeah. So I'll preview of previous part. Now for making that base, I would first need to move this point up and then again make a polyline. So that point was this one. I'll use a Z vector. I'll to move this. So move, put the geometry into move and then vector, and then I can give it. So this was moving. We already have that, the height of the body. So I'll just use the same vector, which was this one. Or extrude surface. Sorry, not this one. I think this one. Yeah. So now we have raised that point to that point, and then now we can connect all of these points together. So I'll just move it a bit back and make a new polyline. I will use merge list. So maybe just flatten tree. So I'll put this in first, and then I'll put this one and this one as well. And then I'll put this into Boolean. And then I would have to again put this in so that it makes a polyline, a closed polyline. So we have this also ready. Now we can use again chamfer for this. So I'll push this down, use the same settings as the previous chamfer, and hide the previous paths and preview this on. So we can see it is also chamfered. Now we have that. Now we want to give it a thickness. So I'll again use the same settings we used previously. I'll first offset this. So offset curve. It has by default gone outside. So we will use the same settings again, which we used here. In distance, it has gone in now. Now we will use loft. So I'll just copy these two. Copy these two again down. Put the curve, the first curve, and then the second curve, and then we can preview this on. So we can see it has already lofted. Now the thing that we want to do is like extrude this. So I'll use extrude, extrude surface. We wanted to extrude in the Z direction only. So we can just use the same settings again that we have used previously. Oh, but this one is going down. So maybe we wanted to be going in the other direction. So I'll just use opposite. And would have to provide another Z unit. And I'll make a node on this vector. Put this in here. Put this in here. Put this in here. Yeah. So now we have now we have this part of the body ready. We can Boolean this together. This could be made neater. There are many ways to do this, but currently we'll just ignore it for the time. Now let's try to make a attachment where the propeller will be sitting on. So we can just have a regular semicircle there. So for that, I'll just go with, we already have a point which we moved to that position, which was this one. We can just use this point for making a cylinder, or we can just use it for making a circle. So I'll just go with circle, origin. We can give it a radius. I'll just go with 5. I have to make this into a range input, and I'll change this to propeller connection radius. It looks pretty small, so we might have to increase that a bit. So there'll be 2 of them, one where it will be housed and the other one would be the larger for giving it some thickness. So this one I can increase to say 10, and the middle one I can just go with a small one, say 2 or 3. 10 is also a bit large, maybe 8. And then I can loft these two together. Loft surface. I put this and this in. You can see I already have a surface. I can extrude this. Extrude surface. And I can give it a height. So that could be called, this could be radius 2. And then we will copy this range input and put it in the vector. We need to give it a vector, so that'll be the Z direction. This will go in there, and then we can call this connector height. Yeah, so we can see it has raised it up. Maybe we can go a bit more, say 5. And then it's going above our unit. Maybe we want it to be lowered, so we can just move it down again. So I'll use, and then I'll give it a vector, and then I'll just maybe push it down by half of the height. So division, this, and then divided by 2. Put the okay, sorry. So we have to give it an opposite direction as well. So the division goes into opposite. that goes into the vector. And I'll preview of the previous part. Maybe it can be a bit more thicker, so I can increase the height. 7, no, I think 6 is fine. And maybe we can increase the depth of these a bit more. They look quite flimsy. Thickness, so we can probably increase it to 5. Yeah. Maybe 4. Great. So now we have these, at least the arms basic parts ready. Now we would want to do is have a connector which joins the arm to the body itself. So first what I can do is I can probably boolean all of these together. So I'll use solid union. Solid union. I'll first put this geometry in, then I can, maybe I'll just flatten all of these together. So flatten the tree, put this in first, put this in, and then put the top one as well, and then put this in into solid thing. It can take some time. Now I think it's done. I'll just hide the previous part. You can see it has been joined into a single object. Now we just want to develop a connector point which connects it to this body. So for that, I can use, okay, let me hide this for some time. I can just go with, so if I'm drawing in a plan, so if I have this arm which is sticking out of that body, I have the connector part which is taking a triangular shape and has a round hair. I can just use a connector which is going inside, but this won't help it stay. So I would have to give it some object that stops its rotation in multiple positions. So I can just make a cylinder there. So a rectangle and a cylinder would do the job to help us connect it. So I'll try to develop that at this point going inside. So we had that point, I think, I can just click this. Yeah. So we had that point here. We will just make a rectangle again from the center. Rectangle by the center. Plug this in here. But you can see it is pointed in the world's origin point, but we want it in the other direction. So I will use this particular plane, which we rotated as the plane for the rectangle. Just a second. Or maybe we can just, there is the point. Yeah. What we can do is we can just make an XY plane again at that point, and then we can rotate this plane. By default, it will rotate to 45 degrees only. So that could become our new plane for generating the XY rotate plane. Yeah, so we have a basic rectangle ready there. We can give it a width and a length. So we can call this, we can maybe have it like 1 centimeter wide. So I'll call this connector width. And then we'll have a connector length as well. Put this in here, put this in here. Reduce this down. Oh, I think I've put this opposite. But this should be width. This would be length. Yeah. So we have the rectangle for that position. Now what we can do is we can have a circle here so that that we can use for making the connection point. So again, at this point, I'll double click to generate a node. Yeah, I'll move this point a bit back. So I'll just move the point. We have a new plane. So we, sorry. Yeah, we have a new plane, so we can deconstruct it again. Plane, so that we can get the directions. And then we can use it for moving the point a bit back. So I'll use amplitude vector. The point we would want to move is the length would be half of the length we have here. So I'll use division by 2 of the length, and this will go into our length, and the vector would be one of these directions, so we can check which one. Yeah, it's correct. It is the x direction. Just move this up. Yeah, but we need it in the opposite direction, so we need to provide an opposite component. We put this here. Yeah. So we have the point in the correct direction. Now we can just make a cylinder. Or let's just make a circle. It'll be easier. So connection point, we don't want it to be too big. Maybe we can just go slightly larger than our width. So our width was 5. So we can just go with 3. Range input, connector radius. I will put this in to this. Increase it a bit more. Yeah. So now we have these two parts ready. Now we just want to extrude them up. But before that, we can just join them together. So I'll use region union for that. And I will put this in and the rectangle in as well. So if I preview of the rest of it, you can see we have a keyhole shaped connector with us. Because we are dealing with DIY objects, when 3D printers come in play, we require some tolerances. So we cannot just subtract the same shape from the body. We require some level of tolerance outside, some level of slightly offset outside, so that the object can be then fit inside. It doesn't have to be exact like fit because of the limitations of fabrication technologies. So we need to add some tolerance to it. So I'll just add that tolerance here. It could be as less as point, like 1 millimeters, half a millimeter or something. So I'll just add, for exaggerating it, I can add like say 1. Range input, I'll call this connector tolerance, and I'll put this in, and then I can use that as for offsetting this curve. Distance, it looks a bit too much, so I'll just go with 0.5. I'll just make a new one. I'll plug this into distance. Yeah, so we'll use the outer one to subtract from the from our body, and then we'll use this one to attach it to our the arm. So if I extrude this now, I can make a boundary out of it first. So I'll just put this in, and then I will extrude this surface up by the same height as the body. So that was Mm, arm thickness. I've lost my own.
I guess we need to introduce node search.
Yeah. Where did I lose it? There's arm thickness. Where is our body? Oh, body's a bit up. Yeah, so there's body height here. So I'll just use this vector. Right. Yeah. So we have raised that up. Now we just need to. So we have it made in one position. We need to polar array it across. So I'll use polar array. This one, I'll put in the geometry. By default, it is using the origin point. So it is coming in the correct position. And then I'll use solid difference. Solid difference. So I'll put these geometries into one, and then body is here. So I'll put this in as well. And if I hide the previous paths, I'll just take it up. Maybe I need to do it opposite. I think there is some.
So solid difference is not behaving today.
Yeah, it's not behaving today. Maybe I should flatten this. It was working previously. Yeah, there's some issue with solid difference.
You have a bug, obviously.
Yeah.
When was the last time you tried? When it worked?
It's just today only. I made the script before and it was working. So might be some. Maybe I can try increasing the height. Where is the Z vector? There's still some issue with this.
Yeah, to bet it happens on the live workshop.
Anyway, I just okay. I'll just show the other one. It was working on that anyways. So we can just move forward. I'll just connect the body height again to I'll just connect this again to that. Yeah, so I mean, it should work ideally. It's probably just a simple bug. So this would then subtract from this so that we can get some outline here, and then we can boolean this to this as this object as well, so that we have a solid object here. So and then we can just rotate this around. So this was a prop. I'll just use polar array. Yeah, so that gives us the other arms as well. So then we can go around printing all of these individually. So for printing them, Wait, what I can just do it, I'll just disable this whole script. It's basically the same thing, and I'll just preview on my previous script.
I wonder whether it works here.
Oh, it should. It is working. It has subtracted the outer shape, and it is boolean in here. It might be. I did flatten it. Solid. Oh, does it go in the same, or was I using some other solid union? Might be the case.
So it's solid difference that has an issue.
There's a solid difference also here. Yeah, there's a solid difference. Might be an issue with this particular component. Some simple bug can be probably modified. So yeah, so idea was that you just have you just boolean this connector to the arm, and you boolean difference a slightly tolerance based cutout into the body, and then you can attach them or assemble them together. This particular one also shows us the battery housing, which would come down. And then what we can do is, for instance, we have this. If I want to 3D print this particular thing, I can type in STL exporter, and I'll just connect the geometry in. I can give it a name, say body, and then I can go into the DIY engineering, and I can export this one. The name will change once you refresh. So you can select this, and then you can export that in high quality. So I'll just try downloading it, and you can see it has downloaded. I can view it in preview already. Pretty simple geometry. One thing I'd like to tell is that I have not currently solid difference the how the chip will attach to this. So the chip will have nut and bolts on all the four corners. So we would have to provide more cutouts there for the screws to go in, as well as we require a housing or a connection point for the camera that will come on the top. So that also needs to have like few more holes on all the four corners. So you can probably see there's some holes here for connecting the chip, and then you have additional holes on these points for connecting the camera on the top. So you require a lot of connector points for this to work. And then some of the rest of the parts can then easily be sorry. Yes, then rest of the part like the propellers, etc., can be. It's not switching. Well, I'll just enable this whole thing again. Yeah. So I've currently modeled them, but these parts could be easily procured from outside, and then we can develop connector points based on how they connect through real life objects, and then we can just use them right away. Just a small. Yeah, so I think this object can then be taken to configurator mode. Because it's a solid difference file, it can take some time to modify, but you can see, I think these are the other scripts parameters, but all your ranges will come here, and then you can modify them in the form through this, and this could be shared with the clients so that they can modify it and then give us an output. So yeah, and then there could be other ways in which you can simulate it, but because it is using online graphics, it can be a bit laggy, but then you can try various things. So yeah, it was a very basic exercise on how to develop a drone frame. Anyone has any questions on any part of?
I like how you animated it.
Yeah, it's a bit laggy, but some parts remain.
Very interesting. No, it gives like a complete DIY functionality that anything which is not available can be modeled, and whatever is, let's say, quicker and more resource efficient to just buy, like propellers, motors, can be just bought in, and I can customize my drone as
Yeah.
per my convenience. So wonderful.
Yeah, that feedback loop can help us a lot. So once you have fabricated something, maybe you will discover that the weight of the drone is too heavy. So you have loading factors. So if the weight is too heavy, then you would have to decrease down certain certain parts of it. So the material needs to be optimized. So the image that you have seen, that you see here, is topological optimization, but it could be much simplified if you have just like a box, like a simple frame outside. So various methods can be used for getting that real life feedback into the model, and then BeeGraphy can help us parametrically modify all of the components so that it makes our life easier and not model again and again.
Yeah.
So yeah.
Perfect.
Great. So should we take
I
a
think
break and then yeah.
we are running behind our schedule, so maybe we can skip the break, Larnik. What do you
Okay.
suggest?
What if we make it like very short? Like,
Yeah, sure.
I thought maybe people wanted to I don't know, go grab a glass of water or coffee.
Yeah, always a good idea.
If anyone has any questions, it's the best time to ask. Alfia, I just read your response. Yeah, I think for the competition, you would have to use external rendering tools. I didn't know about Viscom, but there are plenty of others. Maybe closer to the end of the competition, we can add that feature into BeeGraphy.
That would be nice.
Divya, can I ask you
Yeah.
to share that the buggy script with me?
Yeah, sure. I'll just share this. It's interesting because it was working in the script above, but
Which is in the
it can be in the same script. It was in the same workspace. It was working in the script which I had made previously, but it was not. So might be some geometrical thing. Some yeah.
Ayush had the same problem, right? But by the way, Ayush, did it work when
Yeah.
afterwards?
Yeah.
So even Rhino has Boolean problems a lot. So if your object is just touching at a point and not completely going through another object, sometimes it won't Boolean it properly.
Mm-hmm.
So if two faces are just on each other, then sometimes it can cause an error in Rhino as well. They need to be through and through most of the time.
Mm-hmm. There is one issue I'm aware of is like if it's just touching the edge,
Yeah,
then it will have a problem. Like if it's like tangent.
yeah, that also.
As the direction of the surface, probably, like both the objects are touching to each other. So what are their different, I mean, surface direction, like planar surface?
Hmm.
I think only the development team can answer it the best.
Shall we move on now?
Yeah.
Yeah.
We should.
Perfect. So let's begin our session number 3. We are slightly behind the schedule, but we are learning a lot, so it's okay to spend a few extra minutes around. I start sharing my screen. I hope everybody can see it. And yeah, so this is our target. This is what we want to do. This is what we want to achieve. There is an artist, Andreo. He created this kind of a bench as an outdoor furniture concept. There are a lot of versions available online now. A lot of different architects follow the same language and have some different variants out of it. And we are trying to like follow a similar approach in our, let's say, urban furniture workshop. Our end target to achieve this kind of a bench in the next half an hour to 45 minutes. There are different render modes that can be seen if you want to just play with the visualization. So if it's a basic thing, we can directly get it out of BeeGraphy as well. And these are pretty cool views anyways. Perfect. So how can we approach creating this form? Let's create a basic, let's say, outline of a bench where people will be sitting. And for that, let's take this surface out. Let's create it. There are multiple ways a surface can be created. They were already explained in detail in which like some basic forms, circle, rectangles with chamfering and with rotating around, and then combining the region together can get a surface out. So we can use that. But you are already aware of that methodology. So we are going to use a different one for this one, this part. So simple target, I want to just create this simple surface, which is like this. For it to be like a functional urban bench, it is necessary that my ground connection is completely flat. It is not up and down so that it can be properly attached and let's say rigidly attached to the base. So if we just go to our whiteboard and see what is happening, let me start sketching. So we want a bench where people are sitting on both the sides, something like this. And if I try to break the geometry, what can happen that this part needs to be a flat line, a flat surface, a flat curve here to attach to the ground properly. The other thing which I see that there is like kind of a symmetry along this axis. So what essentially we can do is we can start by creating only this part of the bench, only the one which is highlighted in this pink line. If we have that, we can use the mirroring axis and we get the other half of it. And finally, it is very simple to get this straight line. So what will happen? We will get like these 3 things. The first, which we created, the second that we mirrored, and the third, which is a straight line. And once if we combine all these 3 things together, then we have our complete section profile of the bench. Cool. So now we have parametrically reduced our problem. So from a complicated complete bench to like a small section that we want to achieve. And let's see how we can create it. One methodology you already understood with Divya. So our target is to create now a form like this, the blue curve. I can create like a lot of polylines and then I can chamfer them, but I want a bit more curvy things. So what I'm thinking to use is to have like multiple points around and then somehow creating like a spline out of them, like a curve out of them. So what could be we already understood from our first problem about lighting fixtures that we need anchor points around if in order to control what the combined thing look like. So how many points we are gonna need? Definitely the starting point, the ending point. I will need a point here. I will need a point here. But if we just use these 4 points, my form will be something like this. It won't be like a controlled form. It will be like this pink thing in all the points are covered, but not properly, not giving us these straight sections, which could be like this. I need like a pretty straight section here, yellow, and another straight section here. So what we can do, if we can just add one control point here and another control point here with these 6 points, I am pretty sure that will be able to get this kind of a form. Let's try and test and then see if it happens or not. Great. So let's say I want my mirror axis. I want to mirror along this axis, and I want this to be let's say our normal y-axis, which is 0, 0, 0. So I have to have this point, let's say, in the negative direction. We want the total bench thickness, let's say on the ground, to be 40 centimeters. So this could be like 20 centimeters away. Now following the normal convention of the bench, the height where people sit is around 45 centimeter, 40 centimeter, and the backrest is another 40 centimeter. So we can have the total height of the bench to be something around 80 centimeters. So this is just like a normal parametricization of the problem that you do before jumping into the software to execute it. So I have like a pretty basic idea of the dimensions, what I'm trying to achieve. So based on these basic numbers, I can start creating these anchor points. Again, it is not the only way to do it. We have multiple ways. This is just another methodology, so you are aware with what all are the possibilities where we can achieve something. Starting from a blank canvas, I have a new model, and let's say we design an urban furniture. We get our canvas, blank canvas. I want to see my grid. I want to see the axis, and in a normal basic view. So let me create this point, the first. Pretty standard, no problem at all. I just want it to be moved 20 centimeters towards the left side, which is minus z. So I can start by creating a point, construct point. Right now it is at 0, 0, 0. But as we just saw, we want the 0 axis to be our, let's say, mirroring axis. So in the x, I'm just gonna type, let's say, minus 20. We are working in centimeters right now, so it's like a 20 centimeter. So when it gets mirrored, my base is like 40 centimeter wide. Perfect. I am done with the first point, and now let's do the extreme point on the top, which is, we know that it is just vertically stacked up at 80 centimeter high. Again, a construct point. And Divya already explained wonderfully to you that none of these numbers needs to be number input. If you want any of these parameters to be changeable by your client, or if you want to share it, you can just put a range input, and then in the configurator mode, these things can be changed and altered. So what I have in my center other extreme point, the XY remains at the 0. It's just the Z point, which is at 80 centimeters height. So I am just going to make the Z as 80. So plus 80 height. Okay, I have the 2 points, and now we just have to create the middle points around. Let's create this point here. The one which is here, which is the extreme point where a person is sitting. What is the width we want to give? We are saying it is 20 centimeters, so we can give it like 35 centimeter or 40 centimeter because it is moving out. And in terms of height, we already know that this height we want to be at 45 centimeter, where the people are sitting usually. So let's create this point. So my height where people are sitting is at 45 centimeter. And then the place each person is getting to sit is 45, is like, let's say 50 centimeter. But it is going in the opposite direction. We want it to be on the same side. So I have to put a minus in front of it. Perfect. So I have like this basic output outline. This is my seat. This point, and this point. Now we just have to put some anchor points so that I get like a proper boundary for my seat. Let's put the point behind where they are sitting. It looks a bit high to me. Maybe I get it a bit down, 35. Yeah, looking better now. Perfect. I construct another point. So it's just based on your method, what you feel is parametrically the right approach. For some people, doing multiple points, creating a section may not be the ideal approach, but it's good if you always have like a plan B if something doesn't work out. So this is the point. It is slightly higher than this one and slightly left here. What is the width of the back panel? And let us have it as slightly higher. Earlier it was 35, so let me do it as 45 and slightly on the left side. So let's say -8, yeah, or -10. Too much, -8 is good. Perfect. So these were our 4 basic anchor points. If I just draw this one, what all anchor points we have achieved till now is this one, this one, this one, and this one. This 1, 2, 3, 4. Let's just put these 4 points in the order and then see how our curve looks like. So create like a spline or a curve. Let us go to the tools. In the primitive curve formation, let's see if we find anything spline. We have interpolate. So I have it. Again, to get all the data in, I need to merge them together. I create like a merge list. Let's put all of them together, the 4 points. Remember, whenever we are doing this kind of functions and operations, the order of input is very important. So always go from bottom to top in the order or in the reverse one. But okay, similar to what we expected, that I wanted like a straight back here, but this is for the approach with 4 points is doing fine. It is creating a spline in which all the points are covered, but I'm not getting a straight section here and here. So what we can do, we can just add 1 point here and 1 point here, and hopefully things should work better. So let us construct another point. So what I want it to be slightly higher than this point. So if at this location, so if this point was at 80, let us do 77 or 78, and slightly on the left side. So this one was -8, so I can do it as -5. So I added this one additional anchor point. Remember that I haven't yet added it to the merge list and the spline permission. So it is just a point yet. It is not causing any effect on the red line that we have. Let's create another point here. Let's get it exactly down the same. So -50 remains -50. And the height for this point was 35. It should be slightly lower than this. So let us do 30 or 25. Sounds good. Now let's try to put all of these points together. Again, these points are somewhere in between. So we have to make sure to add all of the points in the correct order. So I have to start again from the beginning. The first point goes here.
Ayush, maybe it will make it easier if you add ports on the list merge.
Yeah. Yeah. But okay, maybe in our next step. Cool. I have an interpolated curve. Let's hide all of them and then see what it looks like. I have like quite a nice chair outline, similar to what I was looking for. We can maybe play around a bit. Let's have this point slightly lower, which is this point. Yeah, it is at 35. How about we do 33? Yes, looking better. Cool. So I have like half a profile now. If I just go to this one, this was the most complicated part. So we wanted to create an entire section, and then we figured out that just by creating one thing and adding a straight line and mirroring it will do the job. So we have a curve already. Let's create a mirror out of it. I get the geometry, and by default, it is set to the correct axis. Otherwise, we can just change we can provide the correct plane input if we want to change it along a different axis. So to create the entire section, the only thing missing now is this straight line. How can I draw this straight line? We already know that this is -20 here, x. So once I mirror it, the x point here will be +20. So we can create like a line from 2 points directly. I can add the 2 points here, x as -20 and here as +20. But I do not want anything in the y, so I put it as 0. And I think it does the job. So these three things combined gives our bench section what we were expecting to achieve. Let us just join them together. First, second, and third. Let us hide everything else. And now we have one curve which defines the section where people are sitting. Let us see how it looks as a surface. We just have a boundary. So we use the command surface curve to surface. And then we see the surface is looking nice as well. So let's say we want to achieve this entire form. We have achieved our basic starting point. Cool. Now let's repeat all of the thing. So our approach, we created one thing. We create this array, this series of different elements. And then in the final step, we will try to manage the variation, how it is happening inside on the table, on the whole bench. So if I see this form, it is a curvilinear form. So which kind of array we should use? A polar array. If it is a linear, a straight line, we could have gone linear, but we have an array in front of us. So let us hide this surface and let's just keep working on this frame around. We need a polar array. The geometry is this one. Right now, what is happening that it is the array is happening with this as the center point, the origin 0, 0, 0. We do not want it because then it is like rotating the same surface, the surface at its center itself. We want to put the point out somewhere here or here so that it gets rotated along that thing. So let us, we can create a point or we can directly change the point. Look here. How about if we take it like 150 outside, we can increase the number of our elements. Let's add it to 100. We do not want it like a complete circular bench. We just have like a portion of the entire circle. So I am not aware with radian wonderfully. So we use the degree to radian command, which should come somewhere. Reloading will help. Here it is, our degree to radian. Let us have a range input as a 90-degree thing, and I apply here as a radian. Okay, looks good now. I have a nice distribution. Let us increase the allowable angle a bit to 180 degree, and then let's increase it. Yeah, looks good. This distribution as a bench looks pretty nice, but it is like still a very small cramped curve here, like people sitting on this side will touch each other. So maybe let's just increase the radius slightly from in the point, center point from 150 to let's say 250. Much better. I have a much larger, wide, spread out skeleton of a bench. And there is nothing much parametric about it. It is like a very simple, extruded, lofted, swept thing. But yeah, it's a good starting point. Now, what we want to do, we want to achieve, let's say, if I show you, we have, let's say all of these are our individual frames, which you'll see here. These all are our individual frames. They all are very boring at the moment because they all are of the same size, the same height. What we can do is we can scale them. We can scale them in a way that some is getting higher, some is getting lower, some is getting very lower, and so on, so that we can create like this kind of a dynamism and a curvilinear form out of it, which is actually in the in our reference example, that we get some kind of a like a variety and dynamism in the overall form. And how we can do it? It's pretty simple. I just need to scale each of my individual element. So for example, in this polar array, we have 100 frames, we can decrease it, we can make it 90, 80, whatever the number we like. So I have 90 frames, and I can just scale all of these frames in a particular pattern. So let's say this frame is getting scaled at 0.5, something is getting 0.6. If something is getting higher than our normal height, it could be scaled at 1.1, 1.2, and so on. Doing it manually is possible, but it is definitely not parametric and a smart way to do it. So we will use something to achieve it. Let's see what can be done. We want to scale it, so let's use the scale component. I have the geometries to scale. Perfect, but something wrong is happening. All of them are getting centered at the same point. What we want is all of the geometries to be scaled separately. We want that this frame here should be scaled based on the bottom point it is connected to the ground. Let's say this frame here should be scaled based on this point. This frame here, the other one should be framed at the bottom point of it. So let's try to find these bottom points for each of them. And how we can do it, we can use a simple command known as evaluate curve, which gives us the point on the curve. So if I do this, what we get let's just hide this thing, we get a point somewhere here. Let's change this parameter where we want the point to be. And if I change it to 1, yes, now I have 90 points related to each of the frame. So each frame is getting their individual scaling point. So we have gotten our points. Perfect. So let's put it in the center. And if I switch it on, it is now working as expected, that all of the different frames are getting scaled based on their individual base point. But if we simply scale all of them to the same factor, there is no play happening. We want this kind of a play in which there is like a unique scale factor following a rhythm or a pattern. And then there is a wonderful component, it's part of Grasshopper as well. It is known as a graph mapper. So what it does is we provide an input in the form of x as between the range 0 to 1, and it provides an output in the form of like 0 to 1 again. So there are multiple kinds of graphs possible. Let us just use anything. Let's use a Bezier curve. And then let's see what happens. We are just creating a graph out of it, like what kind of a pattern we want in our bench, but there is no input in it yet. How many scaling points we want? Equal to the number of frames we have. So to count the number of scaling points which is necessary, we can use list length to identify how many points are there. So let me count how many points are here. Let's say if I add a panel here, we see that, okay, we have a total of 90 objects. So this is just again parametricization. If let's say we change our bench has 84 frames instead of 90, we automatically get that input that, okay, we have 89 division points to take care. So we now know how many scaling factors we want. How can we create a scaling factor? So we can use like a normal series, which is known as list sequence. So in which we start creating like a sequence, like an order. So like a normal arithmetic progression, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 20, 30, whatever it is. So we know that our input range is 0 to 1. So so I have to start from 0 to match with the x input range, 0. How many of these points we want, how many scale factors we want, equal to the number of frames, which we already know by measuring the list length. So we provide that input. And how is the step? how much each point is progressing. We want the max. We know that the X range input is 0 to 1. So the highest point could be 1. So how about if we just divide the count by 1. So it just like gives us the parameter by which each of the numbers should be increased in order to achieve the total as 1. So let's say now it is giving us a list. Let us see in a panel how this list looks like. What we said, I want the number to start from 0. The total count should be 84, which is the length which we entered here. And the maximum number should be the 1. Let's say if it is happening or not. It is starting from 0, correct, checked. The length of the list is 84, 0 plus 83. First, we start from 0, so 83, perfect. And the maximum we are getting is up to 0.988, which is less than 1, perfect. So all of the 3 conditions that we wanted for input in our graph mapper is being satisfied. So now simply add our list and we get an output. So ideally, we should get like scale factors following this kind of a curve. Let's now, we already started scaling it, but it was all at a constant factor right now. Let's add this y here in the scale factor and then see what happens. Something happened, we cannot see. So let us switch off the visualization of everything except the final result. Perfect, looks pretty cool. We have a scaling system which is following this kind of a curve. Now we can do one thing, we can try multiple kind of curves in the graph mapper. Let's say, what happens if it is a sine curve? Great. So it is following the curve, exactly what we wanted to achieve. If I just move the curve around, I see different things coming here. Wonderful. So this is working pretty well. One thing which I don't like is this scale factor, the portion in the middle of the bench is getting super small. So nobody can sit on it. It is dysfunctional. So if you want it to be just like an artistic piece, you can go with something like this. But for me, it is like a functional piece. I want it to be slightly bigger. So what we can do, we can use remapping of the numbers. So what remapping does is it takes a series of the number and then extrapolate them into a certain range by keeping the same character. So if the character is like this kind of a sine curve, the same character will be retained. Just the range in which that character is happening will be shifted, will be changed. And we will see what is exactly happening. For example, I already started with a base curve, which is like a standard seat. So I do not want to go very small. I want let's say the smallest portion to be only like reduced by 30% or 40%. So the smallest should be like 0.6 scaling factor. And biggest, I can just make it slightly bigger than what I already have. So maybe 20% bigger. So the biggest scaling factor could be 1.2. And we have to provide that. Again, what is the target? I want the minimum scaling factor to be 0.6, the maximum scaling factor to be 0.2. This is what I want. What are the numbers I want to remap? These are the numbers which I'm getting after this character is being applied. And now it is asking us to give the source minimum and the source maximum. What is the minimum number out of this by output and the maximum number? And here we can use a component known as bounds, which is meant exactly to do the same thing, which gives us the bound. What is the range in which this series is happening? I provide the list. I add minimum to the source minimum. I add maximum to the source maximum. Now I get, let's me apply a panel and see what kind of output we get after remapping the numbers. We have the length of the series as 84, which is a good sign. It is exactly how many curves we have. And then I see that some of them are 1.2, 1.8, 1, and going down till 0.6, 0.6 here, and then it starts going back up again. Perfect. So the scaling factor are now more rationalized scaling factors. What happens if I apply here? Much better. So I have the form happening, and then the minimum and the maximum thing is also taking place. Let us see what happens if we just change the sine curve. Here, some position. Yes, functioning well. Now let's apply different kinds of yes, it is. I like it. The Gaussian distribution. Let us increase the intensity even further. And let's change the distribution slightly. Perfect. So just you see that there is one parameter about this graph mapper and your entire furniture system can be changed. I like this thing pretty much for now. So let's start, let's move ahead on what can be done next. I got them. Let us, we want it to be made out of plywood or MDF or acrylic sheet or anything. So they need to get a thickness. So how we can do that is we can convert these curves into surface. So let's do curve to surface. Great, I have received all the surfaces. And now we need to provide thickness to all of them. And how can we provide thickness? Our go-to, all-time favorite, easiest tool, extrude. We need to extrude point, no. Curve, no. We need to extrude surface. I provide this surface, and now the default extrusion is happening along the y, the z-axis. But is it correct? Not for my case. I want to give thickness to each one of them. And how can we do that? The thing is, a normal y-axis thickness will not be good as well. Let me explain you why. Because we have applied a polar array. Some of our panels are like this, some are like this, some are like this, some are like this. And finally, let's say some is like this. If we apply extrusion along the y-axis, let's say this is the y-axis shown by this red arrow. For this element, it will be okay. It will be extruded here. It will be extruded here. For this element, it will be extruded like this. So rather than getting like a perfect block, I will get, and when it gets like perfectly vertical, we will get like a surface which is just aligned on itself. So this is not the right thing to do. We need to create find a direction where each of the panel is looking, where each of the surface is located, and then extrude along that direction. So we need to have like a separate vector for each of the surface. So because we have this huge thing, this one will be looking perfectly up, this one looking will be here. That will be the ideal direction to extrude it. Do we have a command for it? Yes, it is known as face normals, which just gives the direction of the normal along the face. So I have a face and what is something perpendicular to it, the vector. If we apply the face to it, we get the normals out of them, which are actually the vectors at the center point, the points you can see here. If I apply the vectors to this vector, let's see what happens. All of them get extruded. Well, yes, but the thickness is very, very less. We can't even see the extrusion thickness. And the sad part is that they are getting extruded multiple times. It is because this output is grafted, like it is getting into multiple trees. So each surface is getting extruded all of the times. So what we can do is we can simply flatten it. And then if I apply here, then it should be only one extrusion per surface based on the normal direction individually that we calculated using the face normal component. Looks pretty good now. You see that there is slight thickness, but it is not enough. I want to control this thickness. I want to identify how much thick my plywood is, how much thick my board is. So what we can do is we can put a component known as amplitude or create vector with amplitude. Amplitude is the weight, is the length, and vector is the direction. So I get the direction from the face normal, and then I supply the length. So vector goes here, and length can be applied by a range, let's say 2 centimeters thick. And let us see whether it is working with 3 centimeters, and then we can reduce it down later. I created this new vector, and let's just apply it. Seems to be working. Yes, now we can see the thickness. All of them are working. And it's in the correct direction. So this face normal component was pretty useful. So we can identify the direction for each of the individual faces. Looks good, but it's pretty thick for me. So let us go with 2. Looks much better now. A 2 centimeter thick board. Yes, wonderful. Okay, so we have now received complete horizontal elements. But if we just go to our reference, we have some of these horizontal elements as well to hold everything together. We are towards the end of the workshop, so maybe just 5 more minutes and we have everything. Again, we are trying to use a Boolean operation with solid intersection and then see whether we are getting through there or not. But otherwise, you already know all the concepts and it is pretty easy to do it. So if I want to do an intersection, we need 2 solids. So first one, that we want the elements to remain just inside our bench boundary. So we can use our surfaces, which is this. So we have all the surfaces. I can create a solid out of it. So we can use like loft solid. And if I put all the surfaces here, let's see what happens. I get a solid out of it. Let me just switch off the visualization of everything else so we can concentrate in this final part. Wonderful. We have the solid bench outline. And now we just have to create these horizontal boards which we can intersect with this. Again, we can use like a normal rectangle, and then we can extrude it. So rectangle is this. First point could be, we just have to make sure the rectangle covers it fully. So it could, the bigger it is, there is no problem, but it just needs to be big enough to cover everything. So this becomes our first point. And second point, let's do 400 or 500 is better. And then y-axis becomes in this direction again, minus 500. Yeah, perfect. So I have this rectangle which covers everything, and then make it into a surface. And then we have to move it up. So we have to move it up in a, like we have to have multiple of these surfaces. As you see here, we have it at like a sequential height everywhere. So we can create again a series, which is a sequence at how many, like what all height we want to keep it to move it up. We want to move it in the Z direction. So move this in the Z. I just need to provide input from the series, how many we have. So let's say we can have a 10. I want 5 centimeter from the ground, and let's say each of them is 12 centimeter or 15 centimeter away from one another. If I do this input here, I see the surfaces happening. Perfect. But these are all surfaces at the moment. They are not solid. So again, our all-time favorite component, extrude surface. We extrude it. Which direction we want it to extrude it to Z. How much thickness we want our plywood to be, not 10 centimeter too thick. We use 2 centimeter there, so we can again use 2 centimeter here. Perfect. And now we want to do a solid intersection. Let's see if it works this time or not. Otherwise, we are already there. Tools, Booleans, solid intersection. Yes. I apply this here. And now we have like one component and multiple other inputs. So let's see what happens if we graft it and then apply here. Let's just give it 1 second and then see what we have achieved till now. We have already gotten all the vertical elements, which are working extremely fine. All the vertical things following our wave idea happening completely okay. And now we are just trying to get this vertical elements integrated somehow. You cannot see it. This is what I was doing. So vertical elements in the wavy format in the blue done, and we just want this pink elements to happen. Let's see if something happened. No, I applied a wrong solid into the intersection. So, and let's hide and then see what it's perfect. This is exactly what we imagined to happen. And it happened as well. That we have these horizontal planes as well now. If I switch on the visualization of our vertical elements, and now we see like a very nice urban table font. But it is still very simple for me. I want to play with the graphs a bit. So we know that by now today that the Boolean operation is pretty time consuming. So what I will do, I will disable this component till the time I'm playing with it. And as soon as I'm satisfied, I will just activate this component. I like this to be like much more happening, even much more dynamic. It is already pretty good, but let's say the sync graph, which is a very bling graph, a lot of things happening. And yeah, this is what I imagined something. And now we can play around with this graph and then move it around left and right and do it till we are satisfied with the form. It is processing everything out. And yeah, this is the kind of urban bench which I'm pretty okay. It's just very long for me. I want to reduce the length a bit. So it's 123 degree. I will make it, let's say 105 degrees. And then let's see what happens. It should ideally just get a bit shorter here. Rest everything should be the same. I should have stopped the solver and then have provided the input, but it's okay. I can do it now. But now let us going back to our drawing board and summarizing everything what we did pretty quickly, because it was a good exercise. We first created our section of the table, which was pretty, let's say, straightforward. There are multiple ways to do it. Then we created our polar array, in which all of the series were copied together. Pretty straightforward. Then final thing was that we used like a Bezier curve to create a scale factor for each of them. So there is a different scale factor applied to all of them. Finally, we used surface normals to provide thickness to each of the individual panels correctly. So all our verticality was done. Then we used to provide our horizontal elements, and then we combined them together. The final step is we will apply material to them, and we are done with the exercise. Okay, I'm satisfied with how it looks. It's not very long. It's at 105 degree. And I'm okay with how this bump is coming here as well. I can enable our solid intersection, which gives us our horizontal line. And I will start the solver. Then we are pretty much done with the form finding thing. We just need to apply the material to make it look nicer. But all our technical stuff is already done. Pretty quick this time, and it looks good. Let's add now final touch, a material, apply material. On what elements we want to apply our materials to? Our horizontal components. Let's flatten all of them before we input there. These elements as well as our vertical extruded. You can provide different materials to them as well. You can just, we can just take two of the material components and then we can apply separate colors as well. Material, we need to apply, give a color. I need like a wooden brownish tone. Looks good. I can switch off the visualization of everything apart from the last material component. And if I go to a rendered mode, looks pretty good. So here we are. I can turn off the view of the grid behind. I do not want to see access. I want a pretty high quality. This is the final view we are getting. And then let's see how it's looking. It's nice to have these kind of furniture in our urban spaces. They will make them much more lively. And the good part is everything is parametric. So if you designed one, just based on the site constraint, you can change a few slider here and there, and you get like a completely different form out. The most interesting thing to notice here is that just by changing one parameter in the graph here, the entire identity and the view is getting changed. And this is the default graph. You can change, you can have a like your own input graph as well, pretty completely customized graph to have a different pattern as an output. So that was it. This was our final third session of the day. Good to see that you are still there, a lot of you. So any questions, any doubts, please go ahead.
Thanks, Ayush. There was. Yeah, there was a comment from Lars when you were using list sequence,
Mhm,
and then you use this division thing.
mhm.
You know, we have list sequence SEC.
I am not aware of that.
Like in Grasshopper, you have range and series.
Yeah.
So in BeeGraphy, one is list sequence, the other one is list sequence SEC, where SEC stands for start and count.
Okay.
So
Okay. So that is perfect. So we could have used that element directly, in which we just say how many count I need. I would have kept the end as 1. So it's already give the input as.
One more comment. I don't know whether you intentionally omitted or maybe you didn't know that it's possible in BeeGraphy. But after the graph mapper, you used a
Remap.
remap. You could also change the y.
The range. The
Y.
Y. Okay.
Yeah, it was from 0 to 1, but you could
Yes,
change.
but it was intentionally done to introduce the element of remapping.
Okay. Yeah, I guessed. I didn't want to intervene. I guess that's the reason. What?
Yeah.
Yeah. One more thing. This is like a hidden feature until we improve it. But in the apply material, users actually apply texture,
Mhm.
and the only texture I know by heart is plywood. The rest are like difficult. So you can use plywood as a text
Yeah.
input. It would apply plywood texture. But the color looked good.
Yeah. That it's like it highlights the form that we are achieving. So
Mhm.
perfect. Abhishek, you want to close the workshop?
Yeah, so I believe we do not have any questions as of now. And thanks for everyone who is still present for the workshop. So the recorded session of this video will be uploaded on the YouTube channel of BeeGraphy, as well as it is available on the competition page under Learning Resources tab. So you can check all the previously recorded workshops over there. Yeah. So for any questions, you already have the Discord server link. You can reach out to us over there. And please come back for the next workshop as well.
Yeah, that's exactly what I wanted to mention. Coding team will do 2 more workshops, and also several of our jurors also agreed to do the workshops. So we will have workshop almost like
Yep.
on a weekly basis. It's gonna be shorter, probably like not 3 hours, but 1 or 2 hours long. We'll see.
Yeah. And just a quick thing. We have 3 categories coming in our next workshop in September. So if you have just reach out anywhere, and then we try to have to include it in the next workshops as well. So any input, any requests you have, just get in touch and we will make it happen.
Ayush, because you were, I don't know, was it on my end? I couldn't hear what you said because it like stopped
I
after.
was saying that in our next coming workshops in September, we will again have 3 categories.
Mhm.
The September workshop will have fashion and jewelry, home furnishing, and education. So
Mhm.
if there is any request from the participants that something they would like us to explore, just reach out and tell us what will be the most interesting thing to you, and we will include that in the next workshop curriculum.
Okay, good. Thanks. Then, if there are no more questions, we can Call it an end.
And just again, like a final reminder, the deadlines are on a rolling basis for the competition. So try to submit before the deadline and don't wait for the last moment to upload your stuff.
Yeah, you can actually publish, and if you want to improve, you can republish. So you don't have to wait until the end. You can publish something what do you call it? Intermediate?
Interim.
Yeah, interim. Thank you. And then republish if you want to, if you improved it, your algorithm.
Yeah.
Yep. Thank you very much,
Thanks,
CODIN.
everyone.
Thank you
Have a good day. Bye-bye.
who joined. Have a good weekend. Bye-bye.
Bye-bye. Bye-bye.